The James Webb Telescope has uncovered a shocking revelation. The universe has stopped expanding. This discovery brings us closer to understanding how our universe began and could eventually end. Famous physicist Brian Cox predicted this years ago, and now we have a clearer view of what that means for the future. The universe's origin is tied to the Big Bang, but the end might not look as we imagined. The idea of the universe ending, often linked to apocalyptic scenarios in science fiction or religious texts, takes on a new dimension when we consider the possibility that the universe's end mirrors its beginning. What if the end of the universe is simply a return to the state it started in? According to the James Webb Telescope, the universe has ceased its expansion, which could signal a significant shift in our understanding of cosmic events. For decades, the Big Bang has been the prevailing explanation for the origin of our universe. Alternative theories like eternal inflation or oscillating universes exist, but the scientific community largely agrees on the Big Bang as the start of it all. The Big Bang wasn't just a simple explosion, but a rapid expansion from a singular point that was incredibly hot and dense. In the first fractions of a second, the universe grew exponentially, reaching from subatomic to golf ball size in a blink of an eye. During this time, the universe cooled, allowing the formation of particles like protons, neutrons, and electrons. Though our understanding of the universe's origins is rooted in theoretical models, many of our insights come from evidence like the cosmic microwave background radiation, which is the echo of the Big Bang. However, this data has its limitations, particularly the inability to detect gravitational waves or the radiation from the very beginning of the expansion. Despite these gaps, the Big Bang theory remains the most widely accepted explanation for the universe's creation. For years, scientists have relied on the Hubble Space Telescope to observe the expansion of the universe. More recently, the James Webb Telescope has provided even more precise data, but its findings have raised new questions. For decades, the scientific community accepted that the universe was continuing to expand, but the James Webb Telescope's recent data suggests otherwise. The universe may have stopped expanding, and this discovery challenges our fundamental understanding of cosmic growth. The implications of this discovery are still unfolding, but one thing is certain: the universe is not behaving as we once thought. As we look toward the future, the James Webb Telescope's groundbreaking findings may lead to a dramatic shift in our understanding of the universe's ultimate fate. But for now, the mystery deepens. What happens next for the universe remains one of the most intriguing questions in cosmology. In popular media and science fiction as a sudden explosion, a massive burst of energy and matter expanding outward in all directions. However, this depiction is misleading. The Big Bang wasn't an explosion in the traditional sense, and understanding its true nature requires a different perspective. Instead of thinking of the universe as having blown up into space, it's more accurate to consider the Big Bang as the simultaneous appearance of space everywhere in the universe. Before the Big Bang, there was no space at all. Space itself has been expanding ever since, carrying matter along with it. This ongoing expansion is often misinterpreted, but the key point is that the universe didn't expand into space. It's space itself that is stretching along with time. For the first 400 million years after the Big Bang, the universe was completely dark, as no stars or galaxies had formed yet. This period is known as the Cosmic Dark Ages. It wasn't until the formation of stars and galaxies that the universe lit up, transitioning out of this dark era. As a bit of trivia, did you know that our solar system formed 9 billion years after the Big Bang? That's right. Our solar system came into existence long after the initial cosmic event. This timeline highlights the significant difference between what is often portrayed in science fiction and the actual scientific understanding of the universe's evolution. The idea of the universe expanding is also misunderstood. The universe's expansion is not like a balloon inflating with objects moving away from a central point. Rather, it's the fabric of space itself stretching. This means that the universe itself hasn't expanded into anything. It's been creating space as it goes. Interestingly, recent findings challenge our earlier understanding of this expansion. For years, scientists believed that the universe was expanding at an accelerating rate, driven by a mysterious force known as dark energy. This theory was supported by observations from the Hubble Space Telescope, which provided evidence of this accelerating expansion. However, new discoveries, particularly from the James Webb Space Telescope, have complicated this view. It turns out that the universe's expansion may not be accelerating after all. This revelation contradicts prior assumptions and suggests that the universe could be entering a new phase, possibly one where its expansion slows or even reverses. While this idea may seem unsettling, it offers new insights into the nature of the universe that could lead to a deeper understanding of cosmic evolution. In the past, scientists thought that gravity would eventually slow down the expansion, pulling galaxies and matter back together. But the discovery of dark energy suggested that the expansion was actually speeding up. This unexpected finding caused a major shift in our understanding of cosmology. In the 1990s, with limited observational tools, scientists had to rely on theoretical models to predict the universe's fate. They assumed that gravity would slow the expansion over time, as the force of gravity between objects would counteract the stretch of space. This idea seemed logical at the time but was ultimately proven wrong by the Hubble Space Telescope's findings. The Hubble observations showed that instead of slowing down, the universe was expanding at an increasing rate. This discovery changed everything scientists thought they knew about the universe's behavior. The acceleration of the universe's expansion is one of the most profound revelations in cosmology, forcing researchers to rethink their models and theories about the universe's past and future. In summary, the Big Bang wasn't an explosion as many imagine. Instead, it was the beginning of space and time, with space itself stretching ever since. Our understanding of the universe's expansion has evolved, and the most recent findings suggest that its expansion might not be as predictable as once thought. The study of the cosmos continues to reveal surprising and sometimes contradictory insights, reshaping our view of the universe's origin and future.